Hi, welcome back. So today I'm going to talk about AE datasets, adverse event datasets. Okay, so the adverse event dataset, basically this is coming under classification of events. So here domain based on the general observation class. This is event class, and it has one record per adverse event per subject. So it will be having multiple records, but so for because each subject has multiple events, right? So we'll be deriving all these variables. Also some understanding of the part of CDS nodes. Okay, so there are control terminology also available, and there is one extra we call as Medra dictionary. So this is we are also mapping these variables also we're mapping because the medical code, the person who does the medical coding, so they usually they allotted the number for this particular variable. So here is a Medra dictionary, so you should have to, you don't need to be understand the coding part, but most of the coding part will be given by the medical coding people. Okay, so this is the adverse event, and this is also at another kind of data set similar like DM and EX exposure what we did in the previous classes. So here we going to continue with doing the peer programming. So here in the R language, so we'll be having the same similar pattern of the header part. I won't be explaining this one now because it's already discussed previous classes. So the similar simple header part, then we will removing if you have any data sets, we are removing with using the rm list ls. So we're removing this part, then we are also calling that all the libraries which are installed in this RStudio. So have an tidyverse, deployer, libdate, an admiral, and a stringer. So the stringer will come for the character strings. So that is the part. And okay, so the libdate function, it works for the dates and time. The basically if you are applying any dates format, so we have to call this library before we applying that dates. Okay, and let me set the working directory and check the working directory is in the right pattern, so which I already changed it to here clinical course. And make sure you'll be having the double slashes. If you have single slash, it won't work. Okay, so then we have called all the raw data sets from this raw data set folder. So I call these ones, and I also call the SDTM data sets for the path of SDTM data sets. Okay, so then we also now we're calling that AE-RAW, that is the dataset, one dataset we have in the raw dataset folder. Let's go into check that raw data folder here and check here. We have like our clinical. So if you go check here in okay, just give me a second. I think it's here the doc and raw dataset. You will be having the SAS7b dat file. So you're having the AE-RAW. Okay, so AE-RAW, we need this data set in order to in order to do this mapping all these variables. Okay, um, so thereafter we have SDTM. We're calling for the DM datasets. AE is there. We got the dataset, and we also got the DM datasets. Oops, I think there is an error. I think this part we don't need it. So now we have a DM dataset which has 48 observations and the 24 variables, 24 total columns. This is the SGTM dataset which we have derived 2 days back, like last class. Let's continue with this AE1. So this is the dataset name we are going to create, and this is the set dataset AE. This is the raw dataset, and this is the assignment operator as I mentioned. So this is the pipe symbol, and the mutate function if you want to add extra columns, if you want to add modified the columns, which so we have to use the function. This is come under deployer package. So the study ID will be having the same thing, the study, as we discussed in that study ID. So here we set to 76515. Let me check in the raw data set. Okay, so here we have study ID. Okay, so here we have a study. This is wrong. 009.01, right? Yeah, 01, that is the one. Then we have a domain name is AE. So the AE, the two character letters AE, because if you are assigning this name, it should be in the capital. It should be in this format, right? Like apostrophes. Then comma is the separator for the next variables. The subject ID will be having the subject ID here. So the subject ID will be there. Here the subject ID. We are taking all those subjects. And unique subject ID is the concatenate of study ID, site ID, and subject ID. Okay, so the site is site ID. Site ID is already be there. Site ID. So okay, we did not verify that part. Okay, yeah, is there site ID, subject ID, and study ID. So all these parts are there. Then AE term, and this is the main key identified. So AE term is the topic variable for this AE datasets. So if you check in the AIG, so you will be see here AE term here, right? So it has the topic variables. So for each individual dataset, you will be having one variable considered as a topic variable. So for this adverse events, the AE term is the topic variable. Okay, so this is the topic variable is the event as per the specification. Raw dot event, and I'm filtering with the required and expected for now. So I'm just consider we have to consider all these variables should be present in our final data set. So raw dot event. So when you check the event, so the event is in all are in capital letters. Okay, let me check if there is event 8 terms and if there is any control terminology for these ones. I don't think so. We have any count, so there is no information. So you can directly mention as a capital letters. Then AE LLT low level term. This is also we just map it to LLT. So this is all part we don't have information here. So we just trying to check in that. So the AE low level term code, and the D code, preferred term code, high level term code, high level group term, high level AE high level group term code, and the body system organ like system the body system organ class. Now the BDA. So all these are Medra variables, right? AEs, all of them are Medra variables. Okay, so these Medra variables we directly map them. You see this is we're converting to numeric format here because LLTCD is in the character format here. So here you see this is a character format, and as per the specification LLTCD, so it is in the numeric format. So all the coding part is in the numeric format, so we need to convert it to the numeric format. Okay, so that's the reason I'm just converting it to the characters to numeric, as dot characters to numeric. Then the decode is a decode, so you just map to the decode part here. The decode is in the capital letters. Okay, in this prop case, sorry. So decode, we map that decode here. There is no control terminology for this part for now. And the preferred term code is as dot numeric. So PTCD is in the characters. If it is in the characters, we these values are considered as a numeric, right? So this has to be converted into the numeric. Then after the high level group term, so I'll just directly map to the HLGT here, high level group terms. Then we have the high level group term code, that is also we consider as a numeric because it is in the HLDCD in the character format, right? So this is in the character format, so we need to change back to the numeric. Then we have a body system organ class, so this is a body system, so you directly map to the body system here. And AE is quite simple simple dataset to create for SDTM. Is you directly map this one. Then body CD, because body SYCD is already in the numeric format, I guess. Let me check. SYCD. You see this is in the numeric with range, so we don't need to convert it into the numeric format because this is already in the numeric. That's why I kept it as BDSYCD. Then SOC part, system organ class, that is we consider SOC. So then after we have SOC code, this is also in the character format here, so we need to change back to the numeric as dot numeric. Okay, so this is as dot character, as dot numeric. It works similar like input function and output function in the SAS. Okay, just change the pattern. If you know one language very well, it is easier to understand. The other language is easier, but you just need to check a few syntaxes. That should be more than enough. Then the string to uppercases, the severity of that AEC SCV. So if you have AESCV here, severity. So let's check. So the SCV here is in the prop case. Let me check how it gives in that, if there is giving any control terminology for these ones. Okay, so here is AESCV and it has given the control terminology. Let me check the control terminology. So control F, control V, sorry. So control C and control F, control V. Oh my god, cannot find the data you are searching for. Oh, okay, so you see here I found this pattern. So this is this code, NCI code we call, and then we have, this is the submission value should be in the capital letters, right? So for that reason we have to change it back to the capital uppercase, string to uppercase, because it is SCV is in the prop case, right? SCV in the prop case, so we need to convert it to the, for the submission purpose we have to convert it to uppercase, string to uppercase. Then we have a string to subster series, A series. Okay, as per the specification, so A series has to be 2 letters, that length is 2 has given, and when you check the control terminology for this one, so when you check the control terminology for this particular ACS variable, and it is giving in either in one letter only, so either S or no. If you have non NA, so not applicable in this format, so you just represent as a sponsor value as NA. Okay, so that's for that reason we are substring from the SCR, because when you check the seriousness, so there is a one letter we have to consider, and for that we are using the string to subster, and this is also we changing back to the uppercase, string to uppercase. So one first position we consider in the first letter. Okay, so for the reason we are taking this one, and then we have action, AE action. So this is AE action, we are mapping to the, you can go to the here as well in the CRF to check how, for example, if you check AE series, it's asking for series, so SCR variable in the raw data set. So you can check the map here as well, in case if the programming notes are not clear, you can go to the annotated CRF, you will be having that information as well there. So for example, AE actions is asking for AECTTT. This is the variable we have to map in the raw data sets. So I'm changing back. Let me check the control terminology for this one. AE actions has 767. Control C. Okay. Control V, then we find that part, and this is also those increase, it is in the capital letters, so they should have to be represented in the capital letters. So that's why I changed to the string to uppercase, and I'm using the strip function, strip WS function. So for that, if they have any case values to strip it, if to compress those ones, so act variables, then I'm gonna check for the next variables, AE action OTH, and AE action OTH is action other. Okay, AE action other. So this is 200. There is no control terminology for this one. Okay, so but so that's why I use COCN as per CRF. I just consider that variable from that raw data set. Here we have, so there is no control terminology, so I'm gonna keep it as it is. Then we have okay, so the AE action OTH, A adverse event action other. I just mapped to the COCN. Then we have AEREL. This is AEREL variable. Let me check the. These are permissible variables, right? This is expected variable. Sorry. So here is the control terminology is as per the requirement. So there is no. So you see here there is a star mark here, right? The star mark represent when you check in the IG. So you have in control terminology, they have given the star mark. The star mark represents If this is something related to the client information, you can keep it as per your client requirements. Indicate variable may be subject to control terminology. So each individual client have their own kind of set of control terminology. For that reason, you can use their control terminology. It doesn't matter. It's not that is a one that is a use of this one, and there is no major point to discuss for this, because if you have a control terminology given by your clients, you have to use that part for a particular variable. For example, here AREL, if you check AREL here, so if you check AREL, find it. Seems like I don't have that information here. AREL. Okay, so let's go to the CRF. We check what is giving the CRF. Okay, in the CRF, the AREL, they have given the raw data set variable CAU to map it. So I'm gonna use I will use that strip function to strip this one CAU. So I'm not gonna use any control terminology here for now, because there is no terminology has given for for this variable. So let's go with the next variable, AE outcome. That is we are outcome. Let me check in the specification, and they have given one control terminology. Let me go check the control terminology here, and find next. So this is in the capital letters. We have to give in the capital letters. Let me check the raw data set for the CAU. So this is in the prop case, so we have to given into the no outcome, sorry, I'm so sorry, outcome. So this is in the prop case, so we have to given into the uppercase, so string to uppercase. So I use that part, and then we have AE contract. This is also, let me check the CRF. AE contract. Okay, I don't have that information here. Let me check here in that one. So the AE contract is a concomitant additional treatment has given. For this variable, we mapped to the COCN. So I don't find any information for this part in the CRF. So because this has a control terminology, right? This has a control terminology for this additional treatment given. So I went to the control terminology, and here we have it has to submitted it in the either sponsor, like single letter, either no or S for the sponsor value. Okay, so here we just collect, we have a substr function here, string to substr function. So we take from one first position and we take the first one. Okay, so up to here we run this part, and I see there is no error here. And let me open this data set AE1. So we got all that particular variables we want. We got it, and we remember we are not using select statement. What are the variables we require? So we are selecting all of them. So we get including those raw data set as well. So these are the variables we have derived. We have mapped to this raw data set. Okay, let's go continue with other variables. Okay, so then we have a DM1. We have to calculate the AE start date and AE end date. Then we have to calculate the study date. For that, okay, so we if you need to calculate AE start date, study date, and AE end date, the start of adverse event and start of study day of adverse event end date, we need RF STDHT. For example, when you check to the here this part in the IG, so you have a study day start of adverse event related to the sponsor defined RF STD. So we have to relative to the reference start date, right? So we need to consider this value starting from reference, like when the subject start for the project until the adverse event is happened. So we have to calculate based on those two dates, right? So let's continue with this one. So we need a DM dataset. So that's why I keep it as a DM dataset from path SDTM. Okay, so then I run. So here we have the same. We getting that all the data from DM1 is a new dataset name, and the DM is the SDTM data, SDTM DM we have created. Okay, so when we have now we continue with the pipe symbol, then we have emitted functions, then we have converting into the DTC is a date format. So we're checking only the date form. We're not considering the numeric. Uh, okay, let me check the DM first. You will understand here. RFSTD will be having the time part as well. So we don't need time part. So we need only the date part. For that reason, I'm just taking that RFSTDTN. Then we select all these three variables. Okay. So we'll be having in the DM1, we'll be having three variables. So RFSTD will be collecting only the date format. So we don't need RFSTDTC right now for calculation purpose. Now we're creating the AESTDTC. In the AESTDTC, so here we have hi, sorry for the because I just kept it as mute for a while. Okay, let me talk about the remaining variables. So AE start date. So AE start date, it is a concatenate function, concatenate of two variables, two start date and start time. So when you check the AE raw data set, we have stop date here and stop time. So this is a concatenation of both. The T is a separator for date and time, and the pace 0 is a concatenate, and we are converting into the character format because this is given as a numeric. This is giving as a numeric now. I don't see here. Okay, it doesn't say anything. So this is in the numeric, so we have to convert because as per the specification, when you check the specification, this is in the character format, AE start date and AE end date. So both are the character formats. So when you see is represented as character format, so this is converting as a character both, then combined with the time. Okay, then we have as start date. We are extracting only the date part off from the AE start date, so that is we consider as a numeric directly, and AE start date here. Then we do the merge with the DM1 and DAE2. So the DM1 AE2 we are going to merge. So once we done this part, AE started and AE ended. Let me run this one. We have AE2 here, have AE start date. So when you check the AE2 here, so there is a if you sometimes the columns are hiding, so you make sure you press this one. Then you can able to visualize visible those the variables you just have created, right? So AE start date, AE end date. So these ones are there. So we got the AE start date in the date format. Once we got it, then we have to combine both AE2 and DM1. So the two data set we combine with inner join by using the unique subject ID. Okay, so E2, this one, and DM1 we combined. Then we mutate A start date, we directly map to analysis start date directly map to A start date numeric format, and A analysis end date is directly format to mapping to AE end date. Okay, then we have a pipe symbol here. Then we have emitted function. We calculate the similar how we did in the EX exposure data set. So we calculating the study date of start date of adverse event here, and if there is any missing values, so we should not be have any missing values. So not equal to is dot na less than or equal to less than to RF STDT, then we consider this part, else we consider as this part. Okay, and we do the same thing with AE end date here. Okay, so we done the similar thing for the formula. This is a formula to calculate the study date, and we have A duration. So the A duration is just taking subtracting from the A start date and AE end plus 1. So the AE duration is AE dur 1. This is the representation purpose. Okay, then we do AE sequence, the row number. So the row number is a deployer package library. So it basically it works to give the ranks to the value of your rows, right? So because instead of your in the exposure we have derive in different way, but this is the one you can also use this one to just giving the sequence for individual, because for one subject, if you have like for example let's see if you have any repeated variables. So here we have one subject has a two events, right? So S23 has a nausea here and S23, so the two records. In order to create, because the same subject, but we have to create a sequence. So this one considered as a 1 here, and this one will be considered as a 2. For that we have to create the sequence, A sequence. The A sequence, we in the R we have a function called row number. So this one you can use it to just multiply the next rows. So Once we read and we run this part, now I check A3 here, last part. So you see here 1, 2, 4, 5, 6, 7. Okay, so here we have a row number. Once we done this part, then we continue with the E3, where we are arranging all, we're sorting all based on the study ID, unit subject, AE decode, and AE start date. Then we select all the variables required. So there are some variables which are not given in the raw data sets. These are the permissible variables. The specification, if you check in the specification, AESP ID. So these are permissible variable. So yeah, so we have some permissible which is not given in raw data set, so we don't consider those ones for now. Okay, if they have given in the raw data set, we have to consider. So these are the variables, we don't need it. So I just put it like that. Then I applied the label for each individual variables. Thereafter I have run these label have applied to the individual variables in the final data set. So we have to use this, we have to call this package library HMIC. Now when you check the final data set, we'll be having that unique subject ID and all those labels are applied. And what are the required variables we need, we will be having the final data set. And then we have created as a final data set as RDS. Okay, when you go and check here, have here, so I'm just cut this one and put it back into the our SDTM dataset. That's it for now. We'll continue with other dataset. Thank you so much for